Hello grade 11s and welcome to this video on question number 3. This question deals with quantitative aspects of chemical change and it will be broken up into 3 separate videos. So this is part 1 of 3 videos on question number 3. I've broken it up into separate videos because otherwise the video would be very long. So at least now you can take breaks in between if you need to. Now, before we look at the question, I would like to remind you of the information available to you in your exams. Firstly, we have a table of constants, and in this table, we have Avogadro's number, the molar gas constant, which we actually don't make use of this year, standard pressure, the molar gas volume at STP, this is specifically at STP, and then we have the standard temperature. So this is standard pressure, this is standard temperature at which the molar gas volume will be 22.4 decimeters cubed per mole. When we take a look at the formulae available to you, the first one takes all of the different ideal gas laws and puts them together. The one that you should be familiar with this year is Boyle's law, which is P1V1 equals P2V2. The formula on the right hand side is the ideal gas equation, which we actually don't make use of this year. When we look below that, we have the formula we've been using from grade 10 to calculate the number of mole using the mass given in grams and the molar mass, which we can calculate in grams per mole using the periodic table. Remember, when you take a look at your periodic table, to calculate the molar mass, you use the bigger number. Okay, so there are two numbers, your atomic mass or your atomic mass number, which is the bigger number, and then we also have the atomic number, which is the smaller number. When you're making or calculating the molar mass, we make use of the bigger number. Then we have the formula that we can use to calculate the number of particles. Capital N is the number of particles, whether that be atoms, ions, molecules, or formula units. This is the number of particles. Below that we have Avogadro's constant that is given in the table of constants as 6.02 times 10 to the power of 23 per mole. And we can use this to calculate number of mole. The formula on the bottom left, very importantly, can only be used for gases. Please do not use this formula for aqueous solutions. We have the volume of a gas divided by the molar gas volume. And if this calculation is done at STP, and only if it is done at STP, then the molar gas volume is going to be 22.4 decimeters cubed per mole. Lastly, we have the two formulae that we can use to calculate concentration. You can either say number of moles divided by volume in decimeters cubed, or you can say mass divided by molar mass times volume to find concentration, which is measured in mole per decimeter to the -3. So now we can take a look at the actual problems. Question number 3 says, in order to determine the empirical and molecular formula of a compound, CXHY, a certain mass of the compound is burned completely in excess oxygen to produce 47.1 grams of carbon dioxide and 19.35 grams of H2O as the products, as the only products. So what are we doing? We are saying CXHY plus excess oxygen is going to produce carbon dioxide and water. This is an unbalanced equation because we do not know the actual formula of this compound. Then they say 3.1.3, define the term empirical formula. For 2 marks, we can define empirical formula as the smallest whole number ratio. So the smallest whole number ratio, must be a whole number please, of elements that make up the substance. So it's the smallest whole number ratio in which elements combine to form a compound. Okay, that is going to get you 2 marks. Question 3.1.2 says, use relevant calculations to determine the empirical formula of the compound. where this compound only contains carbon and hydrogen. Now, this is not the type of empirical formula problem that you're used to, but it's a very nice problem because it's going to make you think a bit more for 7 marks. In the past, whenever we dealt with empirical formulae, we normally gave you percentages and you assumed 100 grams in order that you could determine the mass of the different elements in the compound. In this case, this carbon is going to be forming the carbon in carbon dioxide, or will bond to form carbon dioxide, and the hydrogen is going to form part of the water. Remember, according to your law of conservation of mass, atoms, etc., your atoms are not going to be created or destroyed. They're just breaking apart. The molecules the bonds are breaking and new bonds are forming. So nothing is going to just disappear, and that is why we actually go ahead and balance chemical equations. So what this basically means is, if we have carbon dioxide, and we know that we have 47,1 grams of carbon dioxide. In this carbon dioxide is the carbon from this compound, CXHY. If we are told that we have water, H2O, and we specifically have 19,35 grams of water, then contained in the water as part of the hydrogen is the hydrogen from the compound CXHY. So this is what we're going to do, and of course there are different methods you can use in order to solve this problem. What I'm going to do is I'm going to start off by determining what is the percentage of carbon in carbon dioxide and what is the percentage of hydrogen in water. So I'm going to start off by determining percentage composition. The percentage of carbon in CO2 is going to equal to the atomic mass of carbon, where the atomic mass of carbon is given as 12. Okay, so we have 1 carbon in carbon dioxide, so it's 12 times 1, divided by the molar mass of the entire compound, that is going to be 12 plus 2 times 16, since carbon dioxide contains 2 oxygens. And then we're going to multiply by 100 because we're looking for percentage. In the end, we find out that the percentage of carbon in carbon dioxide is 27.27%. But this is actually a rounded off version, so I'm going to make it 27273%. Okay, so that is the percentage of carbon in this compound. We can now determine the percentage of hydrogen in water. That is going to be the atomic mass of hydrogen, which is 1. There are 2 hydrogens in water, so we say times 2, divided by the molecular mass of water, which is going to be 1 plus 1 because there are 2 hydrogens, plus 16, which is the mass of oxygen. So we say 2 divided by 18, and then we multiply by 100. This gives us a percentage of 11,11111. Remember, we only round off right at the end of the question. So if carbon dioxide contains 27.27% carbon, then in order to determine the mass of the carbon, we can say 47,1 multiplied by 27,27273 over 100 in order to determine the mass of carbon. Without rounding off, we find that the mass of carbon in this compound is going to equal to 12,84545 grams. That is the mass of carbon in carbon dioxide. And that is all of the carbon that comes from this compound called CXHY. Hydrogen, so we go back to the water now. In order to determine the mass of the hydrogen, we're going to take the mass of the water, which is 19,35, and we're going to multiply by 11,11111 over 100. So we're multiplying by the percentage. And without rounding off, we obtain an answer given as Sorry, let's get it right. The pen, it's going to be 2,14,99999. So we're going to have to round this off to 2,15. Okay, so we can't keep 5 decimal places here. It's going to be 2,15. So now we know the mass of carbon and the mass of hydrogen that took part in this reaction. So let's run through it again. What did I do? I determined the percentage of carbon in carbon dioxide and multiplied that percentage by the mass of carbon dioxide formed to determine the mass of carbon. I determined the percentage of hydrogen in water, and then I multiplied that by the mass of the water in order to determine the mass of hydrogen in this reaction. So now that I have the masses of the two elements in the compound CXHY, everything flows as normal for empirical formula. So step number 1, we're going to determine the number of moles of carbon and the number of moles of hydrogen. By saying that number of moles is equal to mass divided by molar mass. For carbon, we say 12,8454 divided by 12, and we get the number of moles as 1,07045. For hydrogen, we take the mass and we divide by 1, and we get the number of moles to be 2,15. Once we have the number of moles in empirical formula, we say carbon to hydrogen is 1,07045 to 2,15. We divide everything by the smallest number of moles. So this is based on the method that you learned in grade 10. So we divide by 1,07045. We end up with 2,00849. Now that we've divided, we check to see, do we have any decimals like 3375 or 0 or 5? We don't. So we can simply round this off, and therefore the ratio is going to be 1 to 2. And this actually brings us to the answer to this question, the empirical formula. Therefore, the empirical formula is going to be C1H2. That is the empirical formula of this compound. I really like this question. Please go through it, go over it. It's such a good way of testing if you really understand your quantitative aspects of chemical change, starting with percentage composition and what it is, and going or moving from there to empirical formula. This question also tests whether or not you understand your law of conservation of mass and the reason why we balance chemical equations. So I really like this problem. So I'm sure you're interested in the mark allocation over here. The marks will be awarded as follows. You're going to get 1 mark for the method that you use to determine the percentage of hydrogen, 1 mark for the method that you use to determine the percentage of carbon. Then you're going to get 1 mark for the substitution that you use to calculate the mass of carbon, and then the substitution for how you calculated the mass of hydrogen. When you were done with that, of course, you determined the number of moles and you divided, so you're going to get 1 mark for this ratio, 1 mark for your ratio of 1 to 2, and then 1 mark for your final answer. There is an alternative method to answer this problem, so if you arrive at the same answer, you're probably on the right track. But if not, please do take a look at the memo for the alternative method. Okay, so that there is the answer to 3.1.2, which again, I really like. Please go and practice it. Question 3.1.3 now says, the molar mass of the compound is 28 grams per mole. Determine by using calculations the values of X and Y. So they're looking for the actual ratio in which these elements are going to bond. So whenever you have a question like this, you know your first step is going to be to determine the molar mass of the empirical formula, which is CH2. That's going to be 12 plus 1 plus 1, giving you a total of 14 grams per mole. We then take the molar mass, 28, and we divide it by, we take the molecular mass of the entire compound and we divide it by the molar mass of the empirical formula. It gives us 2. Therefore, two empirical formulas can fit into one molecular formula. And based on that, we can say the value of x is going to equal to 2 and the value of y is going to equal to 4. Because when we say CH2 and we multiply everything by 2, we get C2H4. And that is your answer to question 3.1.3. The marks over here are going to be awarded as follows. You're going to get 1 mark for your division, so that you got an answer of 2, and then 1 mark for x being 2 and y being 4. So grade 11s, this brings us to the end of part 1 of question number 3. In the next video, we're going to continue with question number 3. So please be sure to join me in that video.